just for fun, let's do a bonus problem. Here I have x is equal to 1 plus 6 times the square root of the quantity x minus 9. Now remember, we're solving because there's an equal sign. And when we solve, we're supposed to isolate the radical, get this radical portion by itself. So in order to do that, the first thing we have to do is move terms over. So I'm going to subtract my 1. That's going to give me x minus 1 is equal to 6 square roots of x minus 9. Now technically, to get my radical isolated, the next thing I would have to do is divide by 6. But then I have to divide this whole thing by 6, which is going to make an ugly fraction, and I don't really like fractions. So I'm not going to do that. I'm going to hold it there, but I need to remember that it's 6 times that quantity. I'm going to go to my next step, which is to square both sides. I'm squaring this whole side, and I'm squaring this whole side. Now, on the left side, just as we did on that other problem, we need to remember that we cannot bring the 2 inside. The x minus 1 squared means x minus 1 times x minus 1. So we're going to actually have to FOIL that out. When we FOIL that out, we'll get x squared minus 2x plus 1. So your outside will give you a negative 1x, your inside gives you a negative 1x. That totals a negative 2x. And then negative 1 times a negative 1 gives you a positive 1. Now, on the other side, we need to make sure that we're paying attention to what's inside our parentheses. We have 6 times this quantity. This is a product inside here. Our laws of exponents say that if we have a product, the exponent can go on both of our factors. So that's going to be 6 squared, which is 36, times, and the square root here would cancel, leaving me this quantity of x minus 9. To indicate that it's a quantity, I must use my parentheses. So once again, the square went inside on both factors because they're being multiplied together. The square here gives me 36. Squaring this cancels each other, leaving me with the x minus 9. Have to take this 36 times this entire quantity, so we must have our parentheses. Now, in order to solve any equation, we can't have parentheses at this point. We have to get things all nice and pretty. So my next step is to eliminate parentheses by using my distributive property. Uh-oh. Let's see here. 324. Now, because I have an x squared, I know that I have to set my equation equal to 0. So that means I'm going to move everything onto this side because you always want to keep your x squared positive. So it's a positive 36x, so I'm going to subtract 36x. I'm going to line that right up underneath my other term with an x so that I have my like terms together. It's a negative 324, so I'm going to add 324 to both sides. They're both negative, so you add the number and keep the negative. They're both positive, so you add the numbers and keep it positive. Don't lose the equal sign. All that cancels out, leaving the number 0 behind. And now we have to factor. Fortunately, again, this is our easier type of quadratic because there's no number besides the 1 in front of that x squared. So we have x and x. It's a positive 325. Positive tells me both signs have to be the same because when I multiply the last, a positive times a positive is positive, or a negative times a negative is positive. It has to add to a negative, so both of them are going to be negative. And now I need two numbers that multiply to 325 but add to 38. Oh boy. Well, the first thing I think of is this ends in 25, which means that there's quarters in there. For every 100, that's 4 quarters, so 300, 3 times the 4, that's 12 quarters plus this 25, so that's 13 quarters. 13 and 25, hey, that's 38. So it's 13 and 25. And now that we have it in factored form equal to 0, we can set each factor separately equal to 0 and solve. X minus 13 equals 0, or x minus 25 equals 0. And then we solve by doing our inverse operation. Add 13 to get x by itself. X is the same thing as 13, or x is the same thing as 25. Remember, the key here is that we have to check our answers. Let's go to a new page. I'm just going to rewrite my equation on the new page. So we have x is equal to 1 plus 6 times the square root of x minus 9. And we have to check both of our answers. So the first one I'm going to check is x equals 13. Right, so wherever there's an x, I'm going to replace it with its equivalent value of 13. So it's going to be 13 is equal to 1 plus 6 times the square root of 13 minus 9. X is always 13 at a time. And now we just simplify using our order of operations. We do not do this addition first. 6 is being multiplied. Multiplication happens before addition in our order of operations. But that multiplication doesn't happen until we simplify underneath the square root. 13 minus 9. It's nice subtracting 9 from a teen number because you just add the two digits together. 13 minus 9 is 3 plus 1, or 4. Now we simplify the square root because remember, this is not the same type of number as the 6. So we have to simplify it to see if we can get it to be. The square root of 4 is 2, still multiplication. Once again, now multiplication is done before addition in our order of operations. So sure enough, 13 is equal to 13. So x equals 13 is one of our solutions. Now you cannot assume that 25 is not. So you still have to check it. Now these markers are a little bit thicker, so I seem to need more paper. Let's write that equation again. X is equal to 1 plus 6 times the square root of x minus 9. And now let's check when x is 25. Once again, wherever there's an x, I'm going to replace it with 25. Same first step, we need to simplify what's underneath that radical. So we have 25 is equal to 1 plus 6 times the square root of 25 minus 9. Once again, we can take away 10 and then add 1. It's 15 plus 1 is 16. Now we have to take the square root of that. The square root of 16, we said at the beginning, is 4, since 4 times 4 is 16. And now we have addition and multiplication. Order of operations says we do the multiplication first. Oh, look at that. That one checks too. So in this problem, both of our solutions check. So the solution to the answer to our equation is that x equals 13 or x is equal to 25. Bonus question number 2. Simplify the square root of x squared minus 10x plus 25. Here's a few things that we cannot do. Oh, there's a square here. Doesn't that cancel with the square root? No, this square is on this individual term. It's not on the entire quantity. You cannot take the square root of individual terms. Remember, our law says only if we were multiplying or dividing. Here we're subtracting and adding. You cannot break that apart to separate ones. Oh, my all-time favorite. Oh, let me just square it to cancel out the square root. You said we could do that. We did that before when we were solving. Square, it gets rid of the square root. Let's think about that. If I square this, how does that keep the expression the same, or an equivalent expression? We squared before because there was an equal sign. When you have an equal sign, you have two sides that are in balance. And because you do something to one side, you do the same thing to the other side to keep it in balance and equivalent to each other. We do not have an equal sign here, so we can't just square to get rid of the square root. That would be changing the value of the problem. The problem isn't x squared minus 10x plus 25, it's the square root of that quantity. So you can't just make it go away because you don't like it. You have to make it go away legally. So you can't take the square root of individual terms. We can't just square it to make it go away. What can we do? Well, the first thing I see is that we have a trinomial. And no matter how badly you hate the F word, I think factor. We still have a square root. You can't get rid of that. But can I make this into two sets of parentheses? Well, let's see. This is the easy kind, so it's x and x. Need two numbers that multiply to 25 and add to negative 10. Well, it has to multiply to a positive, so the signs have to be the same. It has to add to negative, so they both have to be negative. Two numbers that multiply to 25, well, that's 5. 5 plus 5 is 10. So let's put the 5 in there. Okay, so it factors. Now, what do you notice about the factors? The factors are the things that are being multiplied together. So my factors are x minus 5 and x minus 5. What do we notice? They're the same. Anything that's multiplied by itself can be written as what? Anything multiplied by itself. Now don't lose the fact that you still have the square root. Anything multiplied by itself can be written as a square. So because these are the same, I can write that as a quantity squared. So x minus 5 quantity squared is the same thing as this trinomial of x squared minus 10x plus 25. So I didn't change the value of it, I changed what it looks like. And now I have a quantity squared that I'm taking the square root of. Now the two can cancel, leaving me with my base of x minus 5. Interesting how factoring keeps popping up. Use the tools that you know to work things through.